To understand what a standard deviation is, let us first assume that we have the entire population. In this case, the population is very small and consists of only 5 observations. So we have the variable x, and we have 5 observations. So the first observation, we have an observed value of 2. Second observation, observed value of 2 again. Third observation, 2. Fourth observation, 2. And finally, fifth observation is 2 again. Now, the reason I have all 2's is for demonstrative purposes. We've said that there was a total of 5 observations, and because we have the entire population, we use capital N. So N is equal to 5. And what we want to do first is find the population mean. So to do that, we add up all of the observed values and divide by the total number of observations. So the notation for that is x sub I, which we sum up each observation from the first to the fifth, and we divide by 5. N equals 5. So that equals 2 plus 2 plus 2 plus 2 plus 2, all divided by 5. And that is equal to 2. Now, to understand the standard deviation, we first need to understand the word deviation. What deviation means is the distance an observed value, say for instance this observed value, the first one of 2, the distance that value lies away from the mean, the population mean of 2. So here's the population mean, we denote with this symbol, and I'll put it on the other side as well. And the x subscript here just is used to refer to the variable that we are referencing. So we're dealing with the variable x, so we use subscript x. So the deviation is essentially how far an observed value deviates from a mean. Now the standard deviation is an average. It is the average distance that the observed scores lie from the mean here. The calculation for this average is as follows. We start with the first observation, 2, and we subtract it from the population mean of 2. That's what this term here means, and then we square it. So it would effectively be 2 minus 2, which is 0. 0 squared is 0. Now we do that all the way across the numerator for each observation, and we divide by the total number of observations in the denominator. Now, without even doing any calculation, what do you think would be the standard deviation? The standard deviation in this problem is 0, because just by looking at the observed values, they all differ the same amount from the population mean. They all differ by nothing. So the standard deviation is essentially 0. Now to illustrate further, I changed one of the observed values in this data set. I changed the fifth observation to a 7. I calculated the population mean of this data set, which is 3. Now, if we just look at this data set and compare it to the population mean, we can see that the average deviation is not going to be 0, because these values deviate, or they differ from the mean of 3. 2 is differ differs from 3 by 1, and the 7 differs from 3 by 4. So when we do the calculation, as we did earlier, we get 20 over 5. So 20 over 5 is equal to 4. So the average value we get in this case is 4, not 0, because just by looking at the data, we can see variation. Now this calculation we did in both cases, it gives us an average, but when we don't take the square root of the numerator and denominator, we have what is called the population variance, which is denoted with this symbol right here. If we want the standard deviation, what we do is we take the square root. So all we have to do is take the square root of what we found earlier, 20 over 5, which is equal to 4. So taking the square root of that, we get 2. And we use this symbol to denote the standard deviation. So here are the formulas for the population standard deviation and population variance. The calculations that we did earlier were for population variance, but all we have to do is take the square root of that to get the population standard deviation. Now, a very important thing to keep in mind with these formulas is that you want to use subscripts to reference the variable that you're dealing with. In other words, you might see a symbol like this, or a symbol like this, or like that, but it's not clear of what variable you're referencing. In this case it was x, so we have the subscript x, but you could have a variable that you're referencing such as x bar, in which case you'd have x bar as a subscript. Now just going back to the older data set, I've added in the symbols, and we said that both values were 0. And you want to keep in mind that the standard deviation and variance, they're both measures of variation in a data set. And one last thing, these symbols are just Greek letters. This symbol here is a lowercase s in Greek, pronounced sigma, and this symbol here is a lowercase m in Greek, pronounced mu. One last and final note, I just want to fix a little notation problem I had earlier where I didn't have the equal sign next to the ratio here. So I just want to rewrite the population mean with that equal sign so it's clear and you don't think that we're multiplying a population mean by the numerator. It's a very simple calculation, but I just want to be clear. If you have any questions or comments, please post below, and thank you for watching.